When we finished design of the FIREBIRD 2, we began tearing down our studio in the old GM West Grand Boulevard complex in preparation for our move to the new GM Tech Center in Warren, Michigan. Our special studio did not exist in the original plans, so they had to convert a storeroom into a fully functional studio for us, fitting it out with all the same facilities except for windows to the outside. It would also be known as Research Studio, in recognition of our supportive research staff. When we moved in, we would spend a year mostly getting familiar with the facilities. Early in 1957, we had our first assignment to prepare design concepts for the 1959 Motorama. We'd review them later with Harley Earl at a kickoff meeting for that Motorama. As with the FIREBIRD 2, Stefan and I were the only designated designers for our studio. Stefan for mechanical engineering, and I for aesthetics and styling. Our clay modelers had been loaned out to the production studios. We had dutifully resolved that our concept would be a small electric vehicle and represent more conservative design trends. That is, no tail fins. When that kickoff meeting took place, we had built a modest mock-up, and Bob McLean presented its particulars while Miss Earl sat patiently in a wire Bertoia chair. When McLean finished, Earl confirmed that the featured corporation's show car would in fact be the third in the series of FIREBIRD gas turbine vehicles. As to its appearance, it would be spectacular, something like the Club de Mer, a Pontiac Motorama concept car, only larger, to accommodate all the features. The most memorable expression he conveyed, however, was, "You know, when you go to see a floor show in Las Vegas, you don't expect to see your wife on the stage. You expect to see a real floozy." When he finished, he and McLean left the studio. I looked at Stefan and I said, based on his floozy comment, "Well, if we don't put fins on this car, then someone else will." Classically, aviation and aerospace have always been central in pioneering new technologies and have represented the best in what was going on. After a recent air show at Selfridge Air Force Base near Detroit, F-100 and F-104 fighter jets represented the hottest images in body forms. A Nike missile on display also caught my attention, not because of the multiple fin stages, but because it was mounted on a launch rail, and its array of fins were clocked at a 45-degree angle to clear the rail. This in itself presented somewhat of a new look. Seeking a way to get something truly original, I thought that perhaps just a change in the way the design is developed may be sufficient to get a new look. A problem in the past for designs sketched full-size on vellum, these would be on vertical boards so one could step back far enough to see them. Invariably, there would be many dark erasure smudges on it. They would still be visible and therefore would contribute to the design. I had previously thought that string or elastic colored yarns positioned by push pins might be a better means of drawing lines and would eliminate that problem. Perhaps this would be a good time to try it. I placed an order for yarns and push pins. As we were receiving dimensional data and mechanical systems drawings, the pins and yarns arrived, so we placed our worksheets and templates on the vertical boards to try it out. The APU turbine engine and powertrain wheels, joystick controller, 95% Oscar, and the overall length points were set. We were ready to go. Yarns were pinned to the overall lengths, and the intermediate pins were ready to stretch the profiles clear of the hardware. One could stretch the yarns easily, and we subtly realized that variations in pin spacing or variations of angles between straight string placements could give character to the line. Surprisingly, you could almost sense a mathematical purity you could use to actually improve lines, because the eye is sensitive to proportions for making comparative judgments. Secondary elements like blisters could be added easily. The key quad fins were anxiously added as they were important new features and the impact was still unknown at this time. Stepping back, we could see it better as a straight-on side view. A problem developed here. I was hoping that the quad fins would swallow up the rear wheel housings. The rear wheels were a little bit larger already, and that aggravated the problem. Stefan and I were doing the drawing together, and at this point, Stefan walked up to the board and said, "What if we try something like this?" As I watched, he added a large dorsal fin and 2 lower ones. I thought, you can't do that. You can't add a 3-fin feature behind a 4-fin feature. But as I looked at it, it added a mass distribution it was crying for. It didn't really look that bad, but it seemed a violation of some unwritten principle. It could be considered a design flaw, like a birthmark, and sometimes they are known to become beauty marks. So maybe we can live with it. As shown here, the aerodynamic brake flaps could be added, and they mirror the XX and YY axes to establish a sense of 3 to 9 o'clock and 6 to 12 o'clock references. That would put it back into quad ordinances. Stefan and I were pleased with how it was working out and decided to call McLean down from his second-floor office to take a look at it. When he saw the string drawings, he agreed. We may have something. We were committed to continuing what Earl had directed us to do, but McLean authorized us to make a second mock-up to this new design. That put it in my ballpark, as I would have to develop all the surfaces and draw up the section templates. That would take the better part of the next week to do the drawings, and I decided to make a Rowena Reed, that's a Pratt Institute style space sketch, except they would be full size instead of the book size that most of them usually were. It shows how curves can be varied by pen spacing. With McLean's second mock-up approval, I drew in straight line segments between the pins and outlined the templates onto the back sheet of vellum. I then placed a clean sheet of vellum over that and best fit curves to integrate the short straight segments into smooth sweeps. In the end views, I picked station sections that best represented body cuts for character, put sheets of vellum over those section cuts, and drafted notch egg crate type templates, flying model airplane fashion, for the wood shop to make the parts. I did not make an assembly drawing, therefore I would have to identify each of the parts when they came in and tell the woodworkers how to assemble them. The main difference from a typical styling engineering mock-up was that instead of building a dark gray 5-inch gridded plywood platform below, to which templates would be fitted, I designed a cruciform beam on casters, all within the body section, onto which a pair of contoured seats could be hung. This also defined a centerline frame structure, which necessarily would also become primary vehicle structure. The general view would have looked something like this. This sketch is intended to show a few design features that Mr. Earl directed to be changed. There is no good record of the original mock-up as Earl reviewed it. The main changes were the stovepipe inlet, which had about 5 inches of depth added at the center, peaking at the center, and a body flare between the blisters, expanding the interior, where he directed that it be run straight through. This sketch was constructed from a photograph of the as-modified space sketch. Note that the mock-up has clear blisters, meaning that they were vacuum formed from casts taken from the clay model months later. The actual mock-up proved to be a very powerful tool for revealing the form and the space below, capturing the lightness intended for the design. When Mr. Earl entered the studio to review our work, he saw the original mock-up first and then the space sketch, immediately to his right. His brisk entry into the studio swept into a turn where he came directly up to the new mock-up. He had a pleased expression as he came to a stop. Without much discussion and in short order, he declared, "This will be the Firebird 3. And then shortly, "Go to clay." He and McLean left the studio together, and Stefan and I were ecstatic. McLean returned to the studio a short while later with some other good news. He told us that Harley Earl had directed the design committee to stay out of our studio. For approximately a year and a half, the design was executed and resolved to be ready for the 1959 Motorama. The original space sketch remained in our studio this entire time as a guide for our visual objective of what we're trying to achieve. The FIREBIRD 2 clay model was skewered on a spit so that it could be turned upside down to model the underside. It was decided for the FIREBIRD 3 to just elevate the model higher. This overview shows general studio activity and the design personnel. There was a design incident that occurred near completion of the clay modeling when Earl was in Europe for a month vacation and the design committee came by to help. They had the same reaction to the F-fins as I had originally, except they directed us to remove them. We had to comply, and McLean drew the task of explaining it to Earl when he returned. Mr. Earl had a very strong response relating to when he first saw the mock-up. He said, "When I came into the studio that day for the first time and saw the mock-up, I actually saw the finished car in the Waldorf Astoria, and it was exactly as I had pictured it. Now, why don't you all take the car back and put it back the way it was?" He then turned and left the auditorium. To everyone, that was an order to restore the design to its original shape. But to me, it meant that we had successfully captured his vision of the FIREBIRD 3. The photo in this shot is a Photoshop rendition of that change by Brian Baker and is a good representation of what it would have looked like. These last photos give a good overview of the design forms of the FIREBIRD 3. The resolution of complex surfaces is dependent on the execution of that composition. Just as in a painting, in the composition, it must take awareness of everything within its four borders. The fins and surrounding surfaces must take into consideration and recognize the presence and proximity of all the other fins and related surfaces for a successful resolution. It is literally a near quantum mechanics type issue. Note also that even the spectator on the far side is compatible in this composition.